Hi everybody! So in today's video we are going to be getting ready for the 4.1 Ready, Set, Go practice problems, and we're going to start by doing some examples of what we call creating an expression. So the first learning target that we are going to work on is to create an expression that models a given situation. So our goal here is to have an expression at the end of our problem. Let's start by defining what an expression is. A mathematical expression is a mathematical representation that is made using variables, numbers, and symbols. And those symbols can include adding, subtracting, multiplying, or dividing. An example of a mathematical expression would be something like this: 3x plus 5 over 7. Now it's very important to note that a mathematical expression does not have an equal sign. So that's an important note here. An expression does not have an equal sign. We will be learning about creating equations which do have an equal sign, just not at this time. So the end result of our problems here, where we're creating an expression, should not have an equals. Here's how this is going to work. We are going to give you a sequence of events, so words describing what happened, and we are going to ask you to write an expression or create an expression based on that particular sequence. Here's an example. A number of students bought pizzas. So we are going to call the number of students that bought pizzas X. It says that after the second week, the number of students that bought pizzas increased by 10. As soon as I see these words, increased by 10, it tells me that that's a mathematical operation. Increased by means add. So in my expression, I'm going to take the x that I started with, and to show that the value increased by 10, I'm going to write plus 10. When I read the next step in this scenario, it says after the third week, the number of students who bought pizzas tripled. Now the key word here is the word tripled. The word tripled means multiplied by 3. In order to show using symbols that the number of students who bought pizzas multiplied by 3, I would do 3 times whatever I already had. In this case, what I already had was the x plus 10. So you'll notice I kept the part of the expression I'd already created, and I added in, I made it longer by adding in 3 times that parentheses. The parentheses here is really important. It's important to have the parentheses because it tells us that we're multiplying this entire quantity by 3. If we didn't put the parentheses there, it would not have the same mathematical meaning. In part D here, it says, in week 4, the number of students who bought pizzas decreased by 9. The key words here are decreased by 9. Decreased means subtract 9. So if I was to try to show that mathematically, I would take the expression that I had before, which is 3 parentheses x plus 10, and I would put in a minus 9 at the end to show that I had this amount before and I subtracted 9. It decreased by 9. This answer right here is our final answer. We've created a mathematical expression that represents the series of events that we were provided with. In the set part of your practice problems, we are going to ask you to apply properties of operations. So apply properties of operations to determine equivalence. Determining equivalence means decide whether two expressions have the same meaning or not. And in order to do this, you're going to need to have some strategies for simplifying an expression. Now, some of the strategies we're about to discuss are things that you've already heard and learned this year, and some of the things are going to be a little bit different. So let's start with something we already know. The first thing we're going to discuss here is the idea of distributing. When we distribute, it's like passing out a pile of papers. Distributing is always multiplication. And we're going to multiply by everything that's inside the parentheses. So when I see this 3 on the outside of the parentheses, I'm going to distribute by passing it out or multiplying by everything that's on the inside. 3 times x would be 3x, and 3 times -4 is -12. The second mathematical strategy that we have for simplifying an expression is combining like terms. Now, you've seen this before. Combining like terms means putting terms together that are alike. In this problem, there are two groups of like terms. The first thing I notice is that I have one term at the beginning, 4x, and another term in the middle, 5x, that both have x's. When I combine these two terms, 4x plus 5x would be 9x. However, I also notice that this -7 and this +2 are another group of like terms. They go together because neither of those numbers has a variable. So when I combine those, -7 plus 2 would be -5. You'll notice that my simplified expression, 9x minus 5, does not have any like terms left. That's how I know that I combined them all, is that there's no like terms left that could be combined. Last but not least, one of the mathematical strategies we're going to use a lot in this unit is the idea of dividing. When I see an expression like this, where the numerator has more than one term, it has a 15x and a -20, and I'm dividing by a number, what I can do to simplify this is break this up into two problems. I can actually simplify this expression by rewriting it as 15x divided by 5, and then separately -20 divided by 5. So all I'm doing is I'm taking the 15x and giving the 5 the denominator of that term, and the 20 and making 5 the denominator of that term separately. Instead of one fraction, I now have two. Here's why this is a good strategy. 15 divided by 5 is an answer that I know. It's a nice number. 15 divided by 5 is 3, and then I just copy down the x. Minus 20 divided by 5 is a nice number. It's a number that I know. The answer is 4. Now we're going to practice using those simplification strategies to do what we wanted to do, which is to decide whether two expressions have the same meaning. So on the next page, I'm going to give you two different expressions, and our job is going to be to determine whether these two expressions are equivalent or not. For the first expression here, this one can be a little tricky, so I want to point out kind of a sneaky thing that happens sometimes in these problems. One of the things that I want you to know is that if you see a problem like this, where there's a minus on the outside of the parentheses, there's really an invisible -1 here. So my first step is going to use my distributing strategy to simplify this. I'm going to distribute the -1. Now you might be wondering, what happens with the 13? Well, with the 13, I'm just going to drop it like it's hot. Just copy it down. -1 times 2a would be -2a, and -1 times -5 would be +5. Now I'm looking at this answer and I'm thinking, wow, I just noticed that there are some like terms. So I'm going to use another one of my simplification strategies, which is to combine like terms. The 13 and the 5 are alike because neither of them has a variable. So 13 plus 5 would give me 18, and I'm just going to drop down the -2a. Just drop it like it's hot. After I've done two simplification steps, I distributed and I combined like terms, what I'm noticing is that these two expressions are the same. Since those two expressions are the same, I would say yes, these are equivalent. For the second problem here, in order to determine whether these are equivalent, I'm going to start by working on the first expression. What I'm noticing is I have a fraction in this expression, so I'm going to use my dividing strategy to simplify this expression. I'm going to rewrite this as two separate division problems. 24b divided by 2 minus 12 divided by 2. Now what I can do is simplify each one separately. So 24 divided by 2 is 12, and I'm going to copy down the b, minus 12 divided by 2 is 6. Now that's a great way to simplify this first expression, and again I can tell that I'm done because there's nothing else to do. I can't distribute and there are no like terms. Another thing I'm going to do now is simplify the second expression. I'm noticing that there's a possibility to distribute here. It seems like a good strategy to use. When I distribute, I get 12b minus 6. Now that I've simplified, it's become obvious that these two expressions are the same. So yes, they are equivalent. Last but not least, in this video, we are going to be practicing for our go that's part of our Ready, Set, Go. So in our Ready, Set, Go, we are going to be asked to graph a linear function using a table, equation, or a situation and context. In this case, we're going to be working with equations. We need to think back to something that we learned quite a while ago in Module 2, which is that every equation has key features that we can use to help us make a graph. The two key features that we would look for in an equation like this, which is linear, are the starting point and the slope. In this equation, the starting point can be found by looking for both an x and a y. To find the x, I would look inside of the parentheses by the x. If I see a -4 in there, right here, then I know that my starting point actually has a +4. Because if this is a negative, then to get back to 0, I would use a positive. I can get the y coordinate by looking at the number that's on the outside of the parentheses that's being added or subtracted. In this case, that would be -7. Our slope would be the other number that's being multiplied by the parentheses. So the slope here would be +1/2. In order to graph this, I would start by graphing my starting point, which is 4, -7. So I would go to the 4 and then down 7, and I would graph my point. Then I would use my slope to go up 1 over 2, up 1 over 2, and finish off my graph that way. So my graph would look like this. Last but not least, in a very similar question, we are again going to need a starting point and a slope. Again, our starting point has two components. It has an x and it has a y. However, this time I'm noticing there is no number trapped inside of a parentheses by the x, so the starting point must have been 0. The y coordinate would be the number that's being added or subtracted to the x, which is 6, and the slope would be the number that's being multiplied by the x, which in this case is -3. Now I like to write -3 over 1. It makes it more obvious to me that I'm going to go down 3, right 1. From here, I'm going to go to 0, 6, which is right here, and then I'm going to go down 3, right 1, down 3, right 1, down 3, right 1, and continue to graph. Then I'm going to draw my nice straight line, and I'm done. All right, thank you guys so much for watching. I will see you for some practice in class tomorrow.